Okay, this is the part on page 2, and we covered all the numbers that are non-zero, and non-zeros are all significant. Okay, now we're going to be talking about when the zeros are or are not significant or not considered. When I say significant, I mean the ones that are being measured. And there are some zeros that aren't considered being measured. Okay, so the first rule with zero rules is that zeros sandwiched between non-zeros are always significant. Okay, so when you have zeros in between, the 3, 9, and 1 are significant, and so is a 0. And then we have 109,003. So this has 4 sig figs. This has 6. And so what I'm saying real quickly is I say sig figs or significant figures. These are the numbers that are considered measured. Okay, so we have 82,024, 5.0603. All of these are considered significant. So there's going to be 5 here, and there's going to be 1, 2, 3, 4, 5, 6 here. Okay, so zeros in between non-zeros are going to be always considered significant. Now, zeros that come before all non-zeros, are never significant. So this is when you have smaller numbers, less than 1, and you've got a decimal, and when you have all these zeros, you're not measuring anything until you get to the 491. So all of these zeros here are not considered measured. And also, if you have a really tiny number, all these zeros are not considered measured either. So the only thing that's significant here is these 3 numbers for 493. On this small number, it's 62. There's only 2 significant figures here. When you have just a small number less than 1, but there's only 0.0, these aren't considered significant either. So this is just going to be 3 digits. Okay, 3 significant digits. The ones that are 1 through 9 are always significant. That's what I was saying on part 1 on the front page. So you have zeros that are between are always significant. Zeros that are before all non-zeros are never significant. These are the ones on the left-hand side, and they're always involving numbers less than 1. Now, there's going to be zeros that come after non-zero digits, and they're only significant if there is a decimal point. So what the decimal point does is it designates that it's been measured exactly. Like here we have 83,000, but there's no decimal point. So here it's only the 83. It's going to be only 2 significant digits. But when there is a decimal point, then all of them are, because you're showing that it was measured all the way to the ones place. This is roughly 83,000, so it's 2 digits measured. The other part of it, it's just being a rough answer. Like roughly, it's 83,000. Here, when you have the decimal point, you're saying it's exactly to the ones place. And so here you have 5 significant digits. Okay. Now, if we have 83 with the decimal with 3 zeros after it, that means it's exactly going all the way past all those zeros, that it's exactly that value all the way out. Not just 83, not 83.0, but exactly all the way out to 3 zeros past the decimal. So it's also going to be 5. Okay, if you just have 83, it's just 2. But if you have all these zeros, you're going to add them on because you're exactly saying how exact 83 is. Okay, so when you have the 50.000, then they're all significant. That's going to be 5. But if you say 90,000, it's roughly 90,000, and that's only going to be 1 digit because there's no decimal. So all these zeros are not significant when they're to the right or after non-zeros because there's no decimal. If we put a decimal right there, it would become significant. Okay, here we have 4,532,100, And so the 4, 5, 3, 2, 1, that is all non-zeros. And then these 2 zeros at the end are not because there's no decimal. So that makes the 4, 5, 3, 2, 1 significant. That makes it having only 5 significant digits. Okay. Then a couple more. These both have decimals. So when you see a decimal, then all the numbers, even the zeros after the measurement, because these are numbers bigger than 1. It's when you have the decimal and you have all these zeros in front, they're not. It's when you have the zeros at the end with the decimal, then they are. So here we have 6 and here we have 3. Okay. So I'm going to run through a couple of these. We have only talked about 5 minutes, so I can do a couple of these. I like you to do more of them, more than I don't even cover, and I want you to do your best. I know you're just learning this for the first time. We're going to learn this all through this week. So I thought this will be a day that I could have you learn these rules, and then we'll reinforce it throughout the week. I also want to go back to the worksheet with all these volumes and go through these answers with you, a few of them, especially on page 2. Okay. So like if we look at this number, we have a big number. We got 10,082 and they got zeros in between. So all the non-zeros are significant. Non-zeros are always significant. We're talking about the zeros and these zeros are in between. So that 10,000 number, it's going to be all 5. Okay. If we take 70 million, it has a decimal at the end, which makes all of the zeros significant. So you're going to have 1, 2, and then all these 6, you're going to have 8. But if you have the 70 million without the decimal point, no decimal point, then it's just 1. Okay. So these zeros are placing just number 7 into the 70 million range. If we have a tiny number and we just have the 2, 5, the 2, 5 is placed in front of these this small number has a 0.00. All these placeholders, these are called placeholders. These are called placeholders. These are not considered significant, okay? You have a big number without a decimal. It does not count because it's roughly 70 million. When you have the decimal, you're saying it's exactly to the ones place. So that's why we're going to say 8, okay? Here we have a small number. Here we have a small number. Here we have a small number. All these that I'm putting a little line beside them, they all are small numbers less than 1. So really the measuring starts way into the smallness of it. And it's 309 is significant. So all this 309 is significant. That's going to be 3. When you have the 0.000339, then again, this 339 is considered significant. These zeros in front are like this example here, where they're all less than 0. They're all in front before all non-zeros are never significant. So if they're in front of having non-zeros, then they're considered not significant. So that's why there's 3 here, 3 here. You can see it again here. These zeros in front are not. Okay, we have these zeros in front that are not. These zeros in front are not. It's when you have zeros at the end with a decimal. When you have zeros at the end with the decimal, then there's going to be 1, 2, 3. That's the non-zeros, always significant. And then these zeros at the end are all considered significant. So it's 84, 2 digits, then the third, and 4, 5, 6, 7. I believe there's 7 here. So that's going to be 7 digits. 4 plus 3 is 7, yeah. So if we have a simple number 1 and it goes all the way to the 4, which is 3 places past the decimal, then the zeros in between count. This is the first rule, zeros in between. So you have the 1 and the 4 with zeros in between. This would be true even if it did not have a decimal. Because they're in between, then they're going to be considered significant. So there's 4 here. We have zeros in between here that count. Zeros in between here that count. Okay, it's when you have the decimal and they're at the end, these are all significant. All of these are. So there's going to be 1, 2, 3, 4, looks like 8, and then the 2 here, so that's a total of 9. Okay, so I'm hoping I'm giving you a lot of examples. when they're all non-zero, like this 1083, a lot of them have a bunch of zeros here. So when you have zeros in between, they are. When you have the decimal, then they're going to be, especially with the decimal, and it's a number bigger than 1, then you're going to be all significant. All of this is significant. So it's 10.830100. It's going to be, I believe, 8 significant digits, because all of them are considered significant. These zeros at the end, this zero's in between, that zero's in between, they're all considered significant because there's a decimal. Okay. When you see a big number like this, it's kind of similar to this. You got zeros in between, you got zeros at the end, but there's no decimal. So then these are not considered significant. It's the 78001 that is, because there's a 1 here and 8, so there's 2 in between are always significant. This does not have a decimal, so these 3 are not. So there's only going to be 5 significant digits, okay? So I'm going to stop here on this part. I just wanted to give you a visual of, to move on back to what we worked on yesterday. And we were trying to determine the values of these volumes, okay? And we also can do these rulers. And you're seeing some of the answers here, okay? But when you have a lot of space in between, you can estimate to the 114, like on this example, because it's 4 lines over from 110. This is 120. So each one of these is 111, 112, 113, 114. And since you're going past 114, we can estimate to the 2. So everybody should have at least 114. It's just you could have a difference here with the 2. Okay. When you have a large space and there's no space in between, other than just there's no lines in between. So here you're between 130 and 140. So you definitely have to have the 13 for 130. But then you're so far between 130 and 140, you're going to put the 3 there. Okay. These bottom two are less than 1. So we have to put the 0.0, and you're going to count over, and there's 10 hundredths between 0 and 0.1. There's 10 lines between it. So since it's between the 6 and the 7, that's why we go 0.065, because it's less than 0.1. So these two are more tricky because they're smaller, but you can at least see my answers, and I can try to go through some more with you live tomorrow. This one, you have to say 1,000, 1,100, and 1,200. There's 100 between here. And since there's no lines in between, we can only estimate to the next number. And I'm estimating a 2. You could make it possibly maybe a 1, like 1110, but you can't do any more than one estimated number. You can only estimate 1. We definitely know it's 1,100 something. So you have the 1,100, and then we're going a little bit further for 1,120. Okay. And then a few more on this page. These 3 are these 4 are the ones that are whole numbers, because they line up right on the line. Because you're looking at 10 increments between 50 and 60, and you're 1 away from 55. That's why it's 56. You have increments here between 5 and 4. There's 10 increments. So each little line, and you're going to a lower number. This is 4, 5. So this has got to be 3. This has got to be 4 something. No, actually, it's got to be, this one's got to be actually different, because I'm now looking at it, because it's 4 and that's 5. So you're going up here, and so this has to be 3.65. I didn't realize that was going down this way. This one's really not unique. Usually you read up. This one's different because it has 4 and 5, okay? This one here, you're going 20 to 30. So these increments are 1. That's 21, then 22, then 23. This is 24. This is 25. So you're in between 23 and 24. That's why you say 23.5. Now this part can be a little different, the last number. Okay, take a look at these answers too, and we can also talk about, like, when you look at them, you can tell, ask me questions tomorrow. What do you think? And we'll figure out why it's wrong. Okay, I got to go now. Time's going to run out.